today we are doing kind of the same thing as yesterday. Now, kind of as promised, yesterday I told you guys that it was going to be a little bit trickier than normal. Today is going to be a little bit easier than yesterday because we're doing kind of the same thing as yesterday. What we're doing today is we are multiplying and rationalizing radicals. So Friday we multiplied radicals. Yesterday we rationalized radicals. Today we're putting them together, except you won't have any super tricky problems that you have to rationalize the radicals, kind of like you had to yesterday. And a lot of the times, the second day you do these things, it gets a lot easier. So I hope today will be a little bit easier for you guys. And I'll have a worksheet for you with any funny jokes on them, so I might just have to read you my joke of the day off my calendar. But book assignment for you today, okay? So today we are going to multiply and rationalize radicals. So no really new information. It's just kind of tying information from Friday and information from yesterday together. So directions, we're just going to simplify. Remember, we have to make sure the radicals are in simplest form. We had those 3 rules yesterday, so make sure there's no perfect square factors underneath the square root. Make sure there are no fractions underneath the square root. And make sure there are no radicals in the denominator. 3 things to make sure it's in simplest form. Okay, so first one. This is a lot like the ones we did Friday. If I have 5 square roots of 3 times 2 square roots of 3. Who could explain to me, talk me through how we would simplify this? Tara?
First, you multiply the numbers outside of the radicals.
Okay.
And then you can multiply the radicals themselves.
Exactly. We're going to use the commutative property of multiplication, kind of rearrange it. You probably start to do some of this stuff in your head, right? You see the things on the outside of the radicals. I know that since this is all multiplication, I can take the 5 times the 2, and I can do that separately, and then I can take the square root of 3 times the square root of 3. So 5 times 2 gives me 10. What do I get when I take the square root of 3 times the square root of 3? Just 3, because it's the square root of 9, and the square root of 9 is 3. So I have to take 10 times 3 to give me an answer of 30. Okay, so like I said, that's more of like what we did on Friday. And then kind of tying more of what we did yesterday. If I have the square root of 3/8 times the square root of 8/3. This is really tying together what we did Friday with what we did today. Because Friday we talked about the product property of square roots. And we learned Friday that I can multiply these together underneath the radical sign. I can take the square root of 3/8 times 8/3. And yesterday, whenever I had the square root of a fraction, we simplified that fraction first. So kind of the same idea here. Instead of just multiplying these out, can I cross-reduce? Yeah, I can divide out a 3, and I can divide out an 8. What am I left with? 1. Now keep in mind, just because I reduce under there, because I reduce those fractions, that doesn't get rid of the square root, okay? This is still the square root of 1, which in this case, what is the square root of 1? Ends up being the same thing, but don't forget, just because you reduce this fraction here, that does not get rid of that square root, okay? You have to be really careful about that. Don't forget about them. Okay, number 3. Another one kind of like that, if I take the square root of 3/4 times the square root of 8/9. Okay, same first step as the last one. Let's multiply these fractions together all underneath the radical sign. Take the square root of 3/4 times 8/9. And just like the last one, let's look and see if we can reduce. So looking at these fractions, can I reduce anything here? What can I reduce? Okay, the 3 and the 9 cancel out. The 9 turns into a 3. The 3 turns into a 1. Anything else? The 4 and the 2, right? I can divide out a 4. Now for this one, really important. Remember, this is not 2/3. I'm left with the square root of 2/3. Okay? Is the square root of 2/3 an acceptable answer? No, why not? I have a fraction underneath the radical sign, so I can't do that. So this is where what we did yesterday. I have to take the square root of 2 over the square root of 3. Is that an acceptable answer? No, why not? I have a radical in the denominator. How do we get a radical out of the denominator? Multiply by whatever we're trying to get rid of. So if I'm trying to get rid of the square root of 3, I'm going to multiply by the square root of 3 over the square root of 3. Okay, look at your numerator. The square root of 2 times the square root of 3. What do I get? Square root of 6. In the denominator, the square root of 3 times the square root of 3 gives me 3. Can I reduce the 6 and the 3? No, they're in different worlds. One's inside, one's outside. Different worlds, can't reduce those. Okay? Is it making sense? Yes, okay. We'll keep moving forward then. Super fun? You guys having a blast? You guys sound so pumped. Number 4, square root of 8 over 11 times the square root of 22 over 32. Okay, so if we go through the same first steps, let's combine this into one multiplication problem underneath the radical sign. So we have the square root of 8 over 11 times 22 over 32. Just like before, can I reduce anything? Yeah, okay, well I can divide out an 11. What else? An 8, right? Okay, now look what I'm left with, 2 over 4. Can I reduce that? You can, but here's the thing. I maybe don't want to reduce that. Anybody know why? It will come out the same whether I reduce it or whether I don't reduce it. But right now I'm left with the square root of 2 over 4, which is not an acceptable answer because I have a fraction underneath the radical sign. So I could reduce it to the square root of 1/2. But if I reduce it to the square root of 1/2, I'm going to have to take the square root of 1 over the square root of 2, and I'm going to have to rationalize the denominator, right? So if I look at this, would I have to rationalize the denominator? If I take the first one and simplify, if I take the square root of 2 over the square root of 4, I wouldn't have to rationalize the denominator. You guys see that? Because the square root of 2, yeah, that's just the square root of 2. But the square root of 4, that's 2. I don't have a radical in the denominator. I don't have to worry about rationalizing the denominator. Make sense? So if you notice that, maybe you don't want to reduce all the way. If you notice that you have a perfect square in the denominator, maybe you don't reduce all the way. Now, if you do reduce all the way, you'd get the same answer because the square root of 1/2 would be the square root of 1 over the square root of 2. To get rid of the square root of 2, we'd multiply by the square root of 2. You get a square root of 2 in the denominator, and a square root of 2 in the numerator, and 2 in the denominator. Same answer, but if you notice that you got a perfect square somewhere, maybe you don't reduce all the way. Make sense? Okay, just some things to look for. If you do reduce all the way, like I said, you'll get the same answer, so no harm done. Okay, number 5. Square root of 3 and 3/5 times the square root of 2 and 1/2. Now keep in mind what we're going to be doing is whatever's on the inside of the radical, we're going to multiply together. Now inside the radical I have mixed numbers. Do we multiply with mixed numbers? No, we don't. We have to multiply with improper fractions. So maybe in the same step where we write this as one radical, maybe in that same step we change them to improper fractions. So I'm going to have the square root of, to change 3 and 3/5 into an improper fraction, we take 5 times 3, which gives me plus 3, 18 over 5. And for the second one, we're going to take 2 times 2, which gives me plus 1, 5 over 2. And then this is the same thing we've been doing, right? What can I reduce here? Okay, the 5s cancel out. Anything else? Okay, I can divide out a 2. What am I left with? The square root of 9, right? The square root of 9 or square root of 9 over 1. Same thing. What's the square root of 9? 3. Okay, it's making sense? Okay, we're almost over the hard part. The last ones are kind of easy. Okay, this is, I will say, probably the last trickier one. The last 4 are super easy. Number 6. 3 square roots of 48 over 9. Okay, now before we start this one, this is 3 times the square root of 48 over 9. Okay? Now, if I'm going to simplify what's inside here, yesterday we always looked, can I reduce this? Could you reduce 48 over 9? Yeah, they have a 3 in common, right? Do we want to reduce 48 over 9? Why not? There's a perfect square in the denominator, so maybe we don't want to reduce. Instead, let's take 3 times the square root of 48 over the square root of 9 and just go ahead and break this up into its 2-part square root here. Okay? And we'll wait for that square root of 48 here for a second. So I have 3 square roots of 48. The square root of 9 is just 3, which turns out to work kind of nicely. Because what do you notice here? Right, the 3's cancel out. Well, that's nice. So I'm left with the square root of 48. Is the square root of 48 my answer?
No.
I may be able to reduce it. If you think maybe you can reduce, probably need to try. So if I take 48 and I take 48, what can you divide out of 48? 2 and you get, and then divide out, and you get, and divide out, and you get, and divide out, and you get, and divide out, and you get. Okay, so looking back through there, I have a pair of 2's and a pair of 2's. So if I have a pair of 2's and a pair of 2's, that gives me a 4 on the outside, left with a square root of 3 on the inside. Okay, question about the first 6. Okay, we'll do 2 more together, and then the last 2 will be for you to try on your own. Number 7, let's say I have 4 square roots of a squared b, and we're going to put that in parentheses. And then in a second set of parentheses, we're going to put 3 square roots of b. Now, I know this looks a little different, right? I've got some parentheses here, but let's look at this. What operations between the 4 main operations, addition, subtraction, multiplication, division, what operations do I have here? Just a lot of multiplication, right? Those parentheses don't mean anything. So really I can ignore them. So this is exactly like that very first one we did. Anything that's on the outside of the parentheses, we're going to multiply together. And anything that's on the inside of the parentheses, we're going to multiply that together. Okay, so 4 times 3 gives me 12. And what do I get when I take a squared b times b? A squared b squared, which is inside the radical. Okay, well, what's the square root of a squared? A, and what's the square root of b squared? So your answer would just be 12ab. I think it works better when I stand over here. Okay, need to move my podium over here. Okay, number 8. Okay, this one's going to be kind of a long one. Maybe not really. Square root of 5x times the square root of 2x times 3 square roots of 10x squared. Last one's 3 square roots of 10x squared. Okay, so I have kind of 3 parts that I'm multiplying together here, but it's the same thing. It's all multiplication. Anything that's on the outside of the parentheses, I'm going to multiply together. So the only thing I have on the outside of the radical sign, the only thing that's on the outside of the radical sign for this one's a 3. So the 3 is just going to be by itself for now. And anything that's on the inside of the radical sign, I'm going to multiply together. So inside the radical sign, I have a 5x, I have a 2x, and I have a 10x squared. What is 5x times 2x times 10x squared? 100x to the 4th. Okay. And what is the square root of 100? 10. And what's the square root of x to the 4th? X squared. So your answer should be 30x squared. Have your answer. Check with what I have on the board. If you got it right, I'll write the homework on the board so you can go ahead and get started on that. If you're not getting this, please let me know, and I'd be happy to look at it.